Air travelers are well aware of the dangers that bad weather brings to flying at altitudes, but especially with the risk involved in trying to get the aircraft back on the ground. Most aircraft incidents occur and accidents occur in low weather visibility. To lessen the risk of landing aircraft in low visibility conditions, the FAA has established visibility criteria to set the minimum allowable landing limits. The criteria, measuring horizontal and altitude visibility, divides these minimums into three main categories, and they're labeled, known in the industry as Category 1 landings, Category 2 or Cat 3 landings. For Cat 1 landings, the minimum visibility is limited to 2,400 feet RVR, or horizontal distance, 200 feet altitude decision height. For Cat 3 conditions, using much more technological equipment and much variations in that technology and avionics, aircraft are able to auto land when there is zero visibility, 0 feet RVR and 0 feet altitude visibility or decision height. Now, what about decision height? Decision height is critical. It is the minimum altitude at which the pilot must make a decision as to whether or not to land, or whether or not the runway is visible and a safe landing can be made, or whether he needs to initiate a go-around. This is the time that he must make that decision. Timing is crucial for the pilot at decision height. At 200 feet above ground level, the pilot has about 17 seconds before ground impact. About 50 feet above ground level, there is only 4 minutes before the airplane will touch down. And so decision height is critical, and the pilot must be ready to make a decision at that point. For this discussion, I want to briefly explain to you about the RALM system. RALM, acronym for Aircraft Landing Minimums. RALM enhances the efficiency and safety of aircraft operating in these adverse weather conditions. RALM enables the aircraft landings that are safer, and these landings within the minimum limits established by the FAA. Using existing ILS equipment, instrument landing that guide pilots to the runway through radios that are converted to visual inspection, airports are adapted to meet with these items to meet the needs criteria established for RALM landing criteria. The makeup of a complete RALM system includes the combination of air equipment, and the personnel. Personnel required to operate and maintain this equipment. Airport equipment. Category 1 airports use a single ILS system with one glide slope, one localizer, and a single marker beacon transmitter. Category 2 and 3 airports use dual systems with independent transmitters, and they also contain extra runway lighting, touchdown zones, etc. The difference between the Category 2 and 3 airports is the signal deviation tolerances. Due to the more critical nature of the lower minimums, a less deviation is allowed at a Cat 3 designated airport. The aircraft equipment. The number of operational instrument landing systems on the aircraft determines its RALM capability. For instance, Category 1 enabled aircraft will usually have at least one ILS system, whereas a Category 3 must have 3 operational ILS systems in order to be approved for Cat 3 use. There's many other systems on the aircraft that interface with the ILS system. Interfaces are used such as airspeed, altitude sensors, autopilot interfaces, flight directors are integrated with that. Engine performance data are used to enable precision, guidance, and for landing information. Equipment used in minimum visibility landings must be continually proven and certified to be used. anytime there's maintenance performed or anytime there's a replacement part, the system must be recertified to prove it's ready to be used in a round landing condition. Personnel involved in this RALM system: trainers, crew members, aircraft technicians, inspectors, airport facilities technicians, all must be properly trained and certified to perform or even to operate the RALM system. Pilots must be certified, mechanics as well would be certified, trainers and such. So everybody has to be certified and recurrent on that certification annually to be able to work or operate the system. The degree of training varies depending on that person's responsibilities and functions in the RALM system, but each one is required to have continual update and recertification. Due to the criticalness of the system and the risk involved, a high degree of professionalism is required to ensure the RALM systems remain reliable and are accurate and dependable. In conclusion, all components in the RALM systems, airport equipment, aircraft equipment, pilot and control, and even the mechanic that just worked on the system, are equally important and must work in unison to maintain a reliable system and safe operation for round landing. For those of you who have never experienced looking out the window at the windshield of the aircraft, desperately trying to make out the runway, wondering if it's even close, in a torrential downpour of rain or hailstorm, or if you've attempted to pierce through that white fog that seems to be thickest right at the windshield point, know this: at 50 feet above impact, it's too late to hope it works.